Hi everyone! In this video, you'll learn how to calibrate a DP level transmitter. More specifically, a diaphragm capillary sealed level transmitter. For this demonstration, we are using a Yokogawa DP transmitter. If you want to understand how these transmitters work and learn the calculation in more detail, I've added a link below. Make sure to check it out. Now, let's jump straight into the setup. Here you can see our complete setup. To calculate and calibrate this transmitter, we only need three things: the specific gravity of the process fluid inside the vessel, the specific gravity of the capillary fill fluid, the vertical distance between the two flanges. That's it. Nothing more. For this experiment, we are using water, so the specific gravity is approximately 1. The capillary fluid specific gravity in our case is 1.26. The distance between the flanges is 500 millimeters. This transparent hose here is used to show the real water column. I marked the percentage levels on the vessel so you can clearly see what 0%, 50% and 100% level look like. Now let's look at the wiring. Black wire is positive plus white wire is negative minus. The supply voltage is 24 volts, DC. Everything is clearly marked, so it's very easy to follow. Let's turn on the power. As soon as we power up, we can see level minus 631 millimeters. Output 0.3%. This is completely normal, and in a moment, you'll understand why. Now let's turn on our HART communicator to check the configuration and calculation points. Inside my power supply, I have a 250 ohm resistor. This resistor is required for the HART communicator to work properly. In general, HART communication needs a loop resistance between 230 ohms and 1100 ohms, and 250 ohms is the most common standard value. Now, let's move to the calculation part. We see that the level is minus 631 millimeters. This value represents our lower range value. When the vessel is empty, there is no process pressure applied on the upper diaphragm. Only the capillary fluid weight is acting on the transmitter. That's why we use this condition as our zero reference. Let's do a quick calculation. Specific gravity of water, x water level, minus specific gravity of capillary fluid, x flange distance. The result is approximately minus 630 millimeters. That's exactly why the transmitter is showing around minus 631 millimeters. Now let's fill the vessel with water. From the transparent hose, you can clearly see that the level is now at 100%. Let's check the communicator again. Now the level is approximately minus 135 millimeters. It's not perfectly exact because I haven't done a zero trim, but that's a topic for another video. Now let's calculate the upper range value. Specific gravity of water times water height minus specific gravity of capillary fluid times flange distance. The result is approximately minus 130 millimeters. That's why our URV is minus 130 millimeters. And that's it. This is how you calculate and calibrate a DP level transmitter with diaphragm capillary seals. If you have any questions, feel free to write them in the comments. You can also check my other video where I explain the calculation in much more detail. If this video helped you, like, subscribe. Thank you for watching, and I'll see you in the next one.